Okay, as we begin example 3, we've got the probability distribution representing the number of marriages, so that's what X is, okay, never married, once married, twice married, etc., that someone aged 15 years or older has been involved in. Based on data from the Census Bureau. So the first thing is the probability histogram. I've already drawn that in. Again, I have my vertical scale going up to 0.6 since my highest value was 575. And everything needs a bar. Now 4 and 5, the probabilities are so small that essentially they look like 0. Like I just basically like traced over the line that's there. That's fine, okay? You don't want it to look like it's any larger than it really is. That's, virtually 0 when it comes to looking at it. But the second question there, what is the shape of the distribution? So what kind of shape is that? So remember, this is the graph that's doing that trailing off to the right. And so that is the shape skewed right, okay? Compute and interpret the mean of the random variable x. So as a reminder, you want to put the x values into L1, the p of x values, the probabilities, into L2, and do one variable statistics using L1 and L2 as the frequency list. You will be reporting the value of mu. Okay, so mu is going to be 0.919, and the units there are marriages, the same unit as x, okay? Then we need to interpret that, okay? Interpret the mean. So what this means is for those age 15 and older, so I'm going to do just 15 plus, the average number of marriages a person has been involved in is 0.919, okay? So that's how many marriages the average person has been involved in. Now we're going to compute and interpret the standard deviation. So the computation should be right there on your calculator using the sigma. So that should be 0.739. And again, marriages is our unit there, same as x. Okay, and we're going to interpret the standard deviation. Okay, so the number of marriages for those age 15 and older differs from the mean by an average of 0.739 marriages. Okay. All right, moving on to D. Find and interpret the probability that x equals 3. Okay, so first thing, the probability that x is 3 comes from going up and looking at the table where x is 3 and finding the corresponding probability of 0.027. Now, what does this mean? Okay, so the interpretation is the probability someone has been married 3 times is 0.027. Okay, because remember x, number of marriages. Okay, probability that they've been involved in 3 marriages, or more commonly, they've been married 3 times. All right, E, find and interpret the probability that x is less than 3. So the probability that x is less than 3 means add up the values of the probabilities for outcomes 0 marriages, okay, 1 marriage, and 2 marriages. We don't include 3. Again, we're strictly less than. We get 0.968. And again, the interpretation. All right, now that Teddy's done barking. All right, the interpretation of what that means, okay? So the probability Someone has been married less than 3 times is 0.968. Okay, and then the last one, question F, find the probability a randomly selected individual was involved in at least one marriage. Okay, at least one. So that is the probability that X is greater than or equal to 1. At least one means a minimum of, okay? At least one or more times. Now, let me point out we have 2 options. We can either add up the probability that somebody was married once, twice, 3, 4, or 5 times, or we can take out the one scenario we don't care about. Okay, this is the same as doing 1 minus the probability that someone has never been married. That's just the faster way. It is not the right way necessarily or the better way. It's just more efficient and it's faster. We get 0.728. If you would rather add up the probability that X is 1 and the probability that X is 2 and the probability that X is 3 and 4 and 5, you will also get 0.728. I will let you decide which one is best for you, okay? And again, it's not about time necessarily or right or wrong. It's about which version you understand, all right?